Hi there guys, welcome to this video where we're going to take a look at another interesting problem from mathematics, and we're going to look at the problem solving process, help you hopefully to develop your problem solving skills when it comes to finding solutions to non-routine problems in mathematics. Okay, so the problem that I've chosen for this particular video to go through is taken from one of my all-time favorite books, Challenging Problems in Algebra, which I've used in several of my previous videos. The authors Posamentier and Salkind. This book is highly recommended, by the way, if you want to give yourself a good challenge to develop your problem solving skills. It's jam-packed full of not too lengthy problems, but nevertheless problems that you've still got to put some serious consideration into when it comes to trying to find the solutions to these problems. So the aim of this video is not really to present a model solution to a particular problem. It's not really the problem or even the specific solution to that problem that we're first and foremost interested in. Really, the problem is being used to illustrate the problem solving process. Okay, so I choose non-routine problems where I've got to figure out a solution to that problem. I've got to go through the problem solving process and then present that to you. So the solution that I present is my solution. I had to go through the problem solving process, and then I kind of report how that went in this video. So some of the problems are much more in depth than other problems, but nevertheless, even for fairly straightforward problems, there's still a process that you need to go through. And what I find is that particularly for GCSE and A-level math students, they can get very comfortable dealing with routine problems, but then they really struggle to develop suitable problem-solving strategies when it comes to dealing with more in-depth problems and more problems that are not routine, that have a bit more structure to them, and so on and so forth. Okay, so from my experience providing tuition guidance and support for A-level and GCSE math students is that those students that go on to get the higher grades typically have higher developed problem solving, or more well-developed problem solving skills. Okay, so my tuition, my one-to-one support and guidance really focuses in on developing the problem solving skills. So if you're interested in preparing for having some help, some guidance and some support preparing for your GCSE A-level maths exams, further maths STEP, so that's 6-term examination paper, or the MAT, the Mathematics Admissions Test, please feel free to get in touch with me. I'd love to hear from you and see what your specific needs and requirements are, and have a discussion with you about how I can help you, because I'd love to help you reach your true potential, to be able to go into your maths exams with confidence, knowing that you're going to smash those exams, knowing that you're going to nail it, and that you're going to secure the place at whichever academic institution it is that you want to go to. I'd love to help you get there. Please feel free to get in touch. I'd love to hear from you. So let's have a look at the problem that I've chosen for this particular video. So the problem is from chapter 14, and it's question number 13. Okay, so what we're told is that if f of x is equal to a0 x squared plus a1x plus a2 is equal to 0, such that a0 is not equal to 0, and a0 and a2 and s, which is equal to a0 plus a1 plus a2, that's not very well written, these are all odd numbers. So a0, a2 and s are odd numbers. Show that, or prove that, f of x equals 0 has no rational root. No rational root. Okay, so first things first, before you try to solve a problem, you need to make sure that you've got a reasonably good grasp of the information that you've been given and what you're being asked to do. Okay, if you don't have a decent enough understanding of either of these, then you're going to have real difficulties trying to solve the problem. It's going to be next to impossible for you to solve a problem if you don't really understand what you're being asked to do. So that's what you need to clarify. So you need to make sure that you understand these terms. And if you're told that these numbers are odd numbers, that's probably indicating that you need to be familiar with some of the properties, some of the basic properties of odd numbers. You don't need to know every single possible property of odd numbers, but you need to know a few basic properties probably, because you're going to have to call on those and exploit those properties in the development of your solution. Okay, you need to know what it means for something to be a rational root. What does it mean for something to be a rational root? Well, it's a root or a solution to this equation, which is a rational number. Okay, well, what's a rational number? Do you know what a rational number is? Well, a rational number is a number of the form p over q, where p and q are integers and q is non-zero. Okay, so half, 3/4, minus 7/10, for example, are all rational numbers. So what we need to show is that there is no rational number p over q such that f of p over q is equal to 0. Right? So you need to get this clear in your mind really before you start to attack the problem, because it's very common for me to have students, my students come to me when they've tried to attempt to solve a problem, and they'll come to me, they'll bring the problem to me, and they'll say, I couldn't make any progress with this. One of the first things I'll ask them is, do you understand what this information means? Do you understand what you're being asked to do? And it'll transpire that in many cases they don't. They don't have a sufficient grasp of the information. So it's unsurprising then that they can't solve the problem. And another difficulty is that sometimes they'll be given information that they'll understand all but one bit of information, let's say, that they're given. And then that one bit of information that they don't understand, they'll just kind of ignore it and pretend it's not there. And they'll try solving the problem without that bit of information, and they can't do it because that bit of information is critical, particularly when it comes to well thought out mathematical problems that will appear in textbooks and exams and things like that. Generally speaking, the information that you're given there's no redundancy. There's no superfluous information. It's all essential to the solution of the problem. It does happen sometimes that there is a bit too much information and somebody finds a very creative way of using of discarding one of the bits of information, actually solving the problem without that bit of information. It does happen from time to time, but generally speaking, that doesn't happen at GCSE and A level. Okay, so if you're missing out a bit of information, if you don't understand what it means, don't necessarily expect to find a solution to the problem. So also, we're given some information here that's in a kind of an unusual form. For example, we're told A0 and A2 are odd numbers, and S is also an odd number. And we're told that S is equal to A0 plus A1 plus A2. Effectively, this is telling us that A1 is also an odd number. Okay, why is that? Well, because A0 plus A2, because they're both odd numbers, if you add two odd numbers together, you get an even number. Okay, so S must be equal to an even number plus A1. But we know that S is an odd number. So that means that the only way that we can add something to an even number and get an odd number is to add an odd number. Okay, so that means that A1 must be an odd number as well. So we've got A0, A1, and A2 are odd numbers. And that's potentially going to be quite useful to us. So what I'm going to go for here is I'm going to use a very common technique in mathematics that we want to prove that f of x equals 0 has no rational root. What I'm going to do is I'm going to assume that f of x equals 0 does have a rational root. Okay, so I'm going to assume the negation of what it is that I'm actually wanting to prove. Now, this might seem like a really bizarre thing to do, but if you've come across things like proof by contrapositive and proof by contradiction, this is a very common technique to use in mathematics to prove things, because what you can do is you can assume the thing. If you want to prove this, you assume the negation of it, and then you show that you get something contradictory out of that. Okay, in some way it contradicts the information that you started with, maybe, or some other known fact. Okay, so we want to prove that B is true. What we do then is we assume not B is true. Okay, assume not B is true, and then we show that not B implies something that is a contradiction. It contradicts it contradicts something that we already know to be true, and it might be that the contradiction is, we get a contradiction of this information that we've been given. So this data we accept as true. That's the given data. Or it might come from something else. The contradiction might be something that shows that 1 equals 2. Okay, something like that. Something not necessarily directly related to this information here, but we get something that's a contradiction. Okay, so and this is a very common thing. I don't want to go into the details of proof by contradiction and proof by contrapositive in this video. That's not the point. But now that I've mentioned it, if you are interested in it, feel free to go ahead and do some more research on it, because one of the aims of these videos is to introduce you to ideas that you may not have necessarily encountered before. So maybe I do something in a video, maybe I take a particular step and you think, oh, I've never seen that technique used in that way before. I didn't know you could do that. And this is an opportunity for you to then ask questions about it. You can ask me, you can ask some of your teachers, or you can start to do further research, independent research. And this is good for you. This is really good to develop your knowledge and understanding in mathematics, to do independent research. Okay, right. So let's assume that P over Q is a rational root of f of x equals 0. So then either, and we're going to assume that P and Q have no common factors. Okay, P and Q are what's the word? Relatively prime. So that doesn't mean that they are prime numbers. It just means that they don't share any common factors other than 1. Okay. So, for example, 5 and 17, well, they're 2 prime numbers, but let's say 9 and 16. Neither of those are prime numbers. Okay, they happen to be square numbers, but they're not prime numbers, but they don't share any common factors other than 1. Okay, so this can only happen if either P and Q are both odd, or P is odd, Q is even, or Q is odd and P is even. So there's only 3 possibilities. We can't have that P and Q are both even, because then that would mean that they have a common factor of 2, okay, which we've already excluded. Right. So let's look at this first case then. So let's get rid of these. We'll come back to these. So either P and Q are both odd, in which case A0 times P over Q squared plus A1 times P over Q plus A2 is equal to 0. By the way, this condition here, A0 is not equal to 0, means that we've got a genuine quadratic expression here. Okay, it's not a degenerate quadratic expression. So that means that A0 P squared over Q squared plus A1 PQ, P over Q, sorry, plus A2 is equal to 0. Multiply through by Q squared. We get A0 P squared plus A1 PQ plus A2 Q squared is equal to 0. Okay, so if P and Q are both odd, then we can deduce from that P squared is odd. We can deduce that Q squared is odd. We can deduce that P times Q is odd. Okay, product of two odd numbers is odd. It's always odd. We know that A0, A1, A2 are odd. So in particular, we've got that A0 times P squared is going to be odd because it's an odd number, A0, times an odd number, P squared. So therefore, A1 times P times Q is also odd because A1 is odd. P times Q is odd. So that means that A0 P squared plus A1 PQ is going to be even. Okay? But an even number, but we also know that A squared Q squared, A2 Q squared, sorry, that should be squared, is odd. Because A2 is odd. Q squared is odd. So that must be odd. An even number plus an odd number can never be equal to 0. Okay? If I've got an even number, say it's 6, the only way that I can get to 0 is by subtracting an even number minus subtract 6. Okay? Or 6 plus minus 6. Same for if this was odd. I'd have to add another odd number to get to 0. I can't add an even number and an odd number together to get 0. It's not possible. So this is a contradiction, right? That's where the contradiction comes from. Because I know, one of the facts that I know about numbers is that an even number plus an odd number can never be equal to 0. So we've got our contradiction. Since an even number plus an odd number is not equal to 0, then P over Q with P and Q odd is not a root of f of x equals 0. Okay, so this is the essence of proof by contradiction. You assume that the negation of what it is that you're trying to prove, and you arrive at a contradiction. And once you get to that contradiction, what that means is that the original assumption that you made is wrong. Okay, it's false. So we assumed that P over Q is a rational root of f of x equals 0 with P and Q relatively prime and P and Q both odd. And what we've done is we've arrived at a contradiction, and therefore that means that this assumption must be false. Okay? Very powerful technique, this proof by contradiction, and very useful. Although having to get into the history of mathematics, it hasn't always been totally accepted amongst mathematicians. Okay, the technique of proof by contradiction. But that's a whole different thing to get into another time. Let's have a look. We're not done yet because we've only considered one possible case. P and Q both odd. Remember, we've got the case where one of P and Q is even and the other is odd. So let's have a look at that case. So let's assume that P is even and Q is odd. So in this case, again, we end up with P squared A0 plus A1 PQ plus A2 Q squared is equal to 0. Okay, so in this case, we've got that P squared is going to be even, Q squared is going to be odd, and P times Q is going to be even. Yeah, an even number times an odd number is even. So P squared times A0 is going to be even. A1 times PQ is going to be even. But A2 times Q squared is going to be odd. Right? Remember, A0, A1, A2 are odd numbers. Odd number times even number is even. Odd number times even number is even. Odd number times odd number is an odd number. But again, we've got even plus even, that's even. we're in the same situation again, basically. We've got an even number plus an odd number is equal to 0. That's our contradiction again. So this combination can't happen. We can't have P and Q both odd. We can't have P even and Q odd. And it stands to reason, really, that we can't have P odd and Q even. I'm not going to bother writing it out because it's basically the same as what I've done here, just with P and Q interchanged. So none of these combinations work. None of these possible combinations work. So the upshot is that because none of them work, therefore, it's false, irrespective of the values of P and Q, the integer values of P and Q, it's false that P over Q is going to be a rational root of f of x equals 0 with P and Q relatively prime. Okay? And that's it. We've proved it. Okay? We've got our solution. That's the essence of the solution to the problem. So what you've really got to do here is you've got to be really familiar with some of the basic properties of, say, odd numbers. Now, odd numbers, you might think not very interesting, but they do have basic properties, and if it's been pointed out to you that these numbers are specifically odd numbers, you need to take that somehow into consideration in your solution to this particular problem. Personally, I didn't have too much difficulty with this. I think I was kind of lucky that I hit on the solution fairly quickly. So initially I was going to try to go for a direct proof. I prefer direct proofs. That's not to say that I've got anything against proof by contradiction or that I refuse to use it or anything like that. It's just I have a preference for direct proofs, but sometimes you've just got to relent. You've got to kind of give in and just accept that proof by contradiction is going to be, even if there is a direct proof that's possible, it's maybe going to be much more complicated and involved than it's worth, and you may as well just go for the proof by contradiction. Okay, so I'm going to leave that there. That brings us to the end of the solution to this particular problem. It also brings us to the end of this video. So short and sweet, thank you for watching, and I'll see you in one of my next videos. Thanks for watching, guys.